Okay, so this is the sheet of notes that you get on the test. I do add one other piece to that, which is Newton's method. But last year there was some concern among the calculus students that they found this difficult to read. Totally get it. If you want to make your own, go ahead. So these are the formulas from your book that relate to economics. We want to apply our learning economics. Raise your hand if you're taking economics right now. Okay, so you could have, that did not make it to YouTube. You can have regular economics. You can have calculus-based economics. So we're going to do just a basic economics application right here. And here we go. Oh, I won't spend much time on this, but okay. So I want to show you how we come up with the important equation here, and the question is how to minimize average. I'm sorry, how to minimize cost. Okay. So let's put together a few equations. We're going to say that C of x represents a cost function. We're going to say that that's a capital C. If you remember from our previous unit a little while ago, we also said that C prime of x, anybody remember what we called the derivative of a cost function? Marginal cost function. Okay, and marginal cost is the cost of producing the next item. Yep. That now we're going to apply it further. Today we're going to minimize cost. We're going to maximize profit. So the other thing that we need to know is we need to know average cost. Okay. And so I'm going to write it like this: small c of x okay. Hey, you can handle it. Okay. We're going to call that the average cost. Okay, go ahead. Now, I want you to think about this, and this is where you got to think intuitively. Let's suppose that I've currently spent $2,000 producing something as a company, and I've produced 1,000 items. What's the average cost? $2. You took the total cost and you divided it by the number of items. The number of items we're producing is X. So we take our total cost and we divide it by X. Big C divided by big C, okay, divided by X is equal to little c. Now, if you were a company producing something, wouldn't it be great if you could minimize the average cost? So if you can minimize the average cost, you like those commercials that, you know, they ask the baby, would you like more cash? And he was like, no, I don't want more cash. Thank you. No. So if we want to do that, if we want to minimize something, you guys learned the other day, the minimum happens where the derivative is equal to 0. So we're going to take the derivative. C prime of x is equal to, so I have to take the derivative of this right here. If I'm going to take the derivative of that, what rule do I have to use? I have to use the quotient rule. Quotient rule says I take the derivative of the top. Derivative of big C is C prime of x, which is the marginal cost function. Very good. Yes. Times the bottom left alone, which is x, minus the derivative of the bottom. What's the derivative of the bottom? 1 times the top left alone, which is, again, c of x. All divided by what? All divided by x squared. Now, if you want to know how to maximize it or minimize it, you set the derivative equal to 0. So if I say 0 over 1 is equal to c prime of x times x minus c of x over x squared, I'm going to use that to write a new expression that would be very useful. What can I do to both sides? I can cross multiply, and if I cross multiply, what happens with the x squared? It goes away, and you end up with something that looks like this. You end up with x times c prime of x, I just wrote the x in front, minus c of x is equal to 0. I'm just going to do a really short step here. I'm going to add the c of x over. I get x times c prime of x is equal to c of x. And if I divide both sides by x, I get c prime of x is equal to c of x over x. Let's pause and reflect. What is c prime of x? What's c prime of x? So when marginal cost is equal to what's c of x over x? Average cost. When marginal cost equals the average cost, we know that we have reached our minimum. So that makes solving these type of problems really nice. We won't ever use the lowercase c again. It was only for the purpose of deriving this equation. So what you have to be able to do on the test is, if you want to be able to minimize, you have to think of the marginal cost equals the average cost. In fact, I have it right here. Minimum cost, marginal equals average, and I write it out for you. All you have to be able to do is understand that. Okay. We're not going to have a small c that we'll use anywhere. Okay. These can all be represented as large c's. Okay. Let's try an example. The cost of producing X items at a factory is given by that cost function. Now, some of you may get skeptical here, and you may say, would we really have a cost function if we were working somewhere? Yes, you can. If you're given a set of data points, computers very easily, in fact, your Texas Instruments calculator can calculate a polynomial to give you a function to represent those costs. So you can do this very, very, very quickly, very easily. So this is real and legitimate. Okay? So what we want to do is we want to determine the total cost, average cost, and marginal cost of producing 1,000, 2,000, and 3,000 items. We also want to find the product level that produces the lowest average cost. I'm just going to make a small table here for A, and you just have two problems from your assignment that look like this, and then you have a couple on the back side that look like the other one we're going to do. So we'll follow right along with. So for A, what we're going to do is we need to find it for 1,000, 2,000, and 3,000 items. And we are going to look at, again, the total cost. We are going to look at the average. And we are going to look at the marginal. So the first test is, can you understand the difference between these types of cost functions? If I want to find the cost of producing 1,000 items, so on and so forth, what would I do with that? I would simply plug it in my calculator. I can make a table and go from there. I already did that. Do you just want me to write it down, or do you want to do it all together? Okay, so if we just plug these into the calculator, we end up with $5,600 we end up with $10,600. We end up with $17,600. So I took 1,000, 2,000, 3,000, and I plugged it into C of X. I plugged it into that function right there. And that generated my cost. Now, does it make sense that if we produce more items, we will, that it will cost us more? But that's okay. If the average cost is minimized, then we know that we're at our best production level. Let's look at the average cost. This one we really don't even need to go to our calculator. $5,600, that's what it costs us to produce. We produced 1,000 items, so what's our average cost? Yeah, so $5.60. So all you did was exactly what the formula says. Take your cost function value and divide it by the number of items. So you're doing exactly what that tells you to do. What about 10,600 divided by 2,000? Yep. If we take the cost and divide it by the number of items. And again, that's from right here. Cost divided by the number of items. The deal is that, because they're nice numbers, we can generally just look at it and figure out what it is. And 3,000, we end up with $5.87. Okay, Marlene said something important. Say that again, Marlene. Yeah, you can see it goes down to 530, then it goes up to 587. So either it reaches bottom between 560 and 530, or it reaches bottom between 530 and 587. Or in other words, our production level will reach bottom, in terms of its minimal average cost between 1,000 and 2,000 or 2,000 and 3,000. We can already see that, but we're going to have to figure that out. So what we need to do is we need to now calculate marginal cost, and then we'll take the derivative in a second here. Question? Not where the marginal function is equal to 0. That will actually tell us when the marginal cost begins to increase again. That will actually tell us, that's the double derivative. It will tell us the inflection point. And we'll look at that when we get to the back side. But right here, we will use the formula that we just derived. First, let's figure out our marginal cost function. Okay? How do we figure out marginal cost? Take the derivative. What is the derivative of 2,600? We're going to list the values there. Right now, I'm going to write the marginal cost function. What's the derivative of 2x? 2. What's the derivative of 0.001x squared? So if you want to figure out the marginal cost, and again, the marginal cost is what it costs to produce the next item, what we will do is we'll take 1,000 and plug it into this. Okay? And if you simply plug it in, 1,000 times 2 thousandths is 2, plus 2 is 4. It's going to cost approximately $4 to produce the 1,000 first item. That's the current rate of change for us. Right, but Taylor, what we're saying is this. By the time you set up your factory costs, you pay for your workers, you pay for insurance, you pay for supplies, you're going to be better off to produce 1,000 objects as opposed to 5 objects. And so that's what we're finding. $4 for the next object, that's a good price for us. Okay? All right. If you plug in 2,000, you get $6. That's costing us more, though. Right. And for 3,000, it will cost us $8. Okay. So to Andrew's point earlier, the marginal cost function is starting to increase. So we know that there's some issue happening here. So what we have is our chart laid out of what it costs to produce these items. We have total, we have average, we have marginal. Now part B says find the product level. So how many items should we produce? That will produce the lowest average cost. We just derived a formula. We said that the lowest or minimum cost we can calculate by setting the marginal function C prime of X equal to what? C of X over X, the average cost function. So we have just derived that. So now we want to go to work and work with this piece right here. What is C prime of X? Equals. What is our cost function? Over X. I need to solve that. What should I do to both sides? Yep. Cross multiply or multiply both sides by an X. If we do that, we get 2x plus 0.002x squared equals 2,600 plus 2x plus 0.001x squared. I'm sorry, I missed something. I was looking for something to cancel, and I had my arm over the 2x. Okay. So Laura says to cancel the 2x's. Good. I can minus my 0.001x squared from both sides, get 0.001x squared then is equal to 2,600. Divide and take the square root, and you will get x is equal to 1,612 items. Does that make sense with our preliminary data? Devin, question. Nope. That means that if that's the minimum average cost. Okay? So our average cost for producing items, it will be at its lowest amount when we produce 1,612 items. So, right away, Taylor said, well, what if we produced an item, for $10, sold it for $11, we make a buck? Well, fine. Maybe it cost us 10 right away, but that was an average of 10. Let's produce more and see if we can get it to go down. After a time, then, it starts to go back up. And that could be because of all sorts of reasons. People start making overtime and collecting more money. It could be because you're working later hours. It could be because you have more mistakes happening the harder you push your workers. But we want this to minimize our cost. Now, there's more than cost. There's revenue and there's profit. Essentially, don't people want to maximize profit? That's what we'll do next. But they like to look at all pieces, yes. Exactly. You guys, Christy raises a really good point, and I'll end with this, okay? Too often in the business world and in real life, we always assume that everything operates on a linear kind of pathway, and that's not true. A lot of times production works like this, okay? The rate of the change is very high at the beginning, then it slows down, then it increases. And like I said, that could be due to how much you're paying workers. There's just so many variables that come into play. You can't simply treat it as linear. It has a higher degree to it than just linear. Right. The cost will always go up, Chrissy. But we are trying to minimize the average cost. And so the average cost function might look something more like that. And if you want to minimize it, then we are looking for that spot. If you take the derivative of that, you get a squared, right? So that's what we're looking for. Okay. All right, so before we move on, this piece right here, you guys see these formulas. Set up your table. Take your derivative, set it equal to average cost. Solve. Any questions? Okay, backside. Profit equals revenue minus your cost. So revenue is how much money you bring in on a daily, weekly, yearly basis, whatever that might be. If we want to calculate the profit, we need the revenue minus the cost. We would have this figured out if we could come up with a revenue function. And we can, but you got to follow a little bit of logic here, okay? We said that the cost function is C of X. But if you want to calculate revenue, if I sold 100 items and they were $5 each, what's my revenue? 500. You took the number of items times the price. So we need to know price. And sometimes price fluctuates. Sometimes it's higher, sometimes it's lower. And so we have a price function. In order to come up with revenue, you need to take the price times the items. The price we'll call a function, P of X. The number of items is X. So let's work this out. Profit is equal to X times P of X minus C of X. The price is P of X, number of items is X. Because I'm a horrible teacher. Profit equals X times P of X minus C of X. Okay, so X times P of X is another way of stating what? Revenue, okay? Revenue. So if you were to take the derivative of this, you would have to use the product rule. But we don't want to talk about that right now, and you're not going to have to do it. So I'm going to rewrite this as follows. Profit equals revenue in terms of X minus C of X. If you want to maximize profit, you need to take the what? Derivative and set it equal to 0. So we're going to take the derivative of profit and set it equal to 0. What is the derivative of R of X? R prime. That's why I wrote it as R, so we wouldn't want to take the, product rule. Minus C prime of X. Now, look, I have another equation, and I can write a very, very simple equation from here. If I add the C prime of X over, I get C prime of X is equal to R prime of X. What does C prime of X represent? When the marginal cost function is equal to the derivative of the revenue we have maximized our profit. Once again, on the front page, it says, and we call the derivative of revenue the marginal revenue, just like we do the cost. So you can see from the front page, I have this formula for you right here. It says maximum profit is the marginal revenue equal to the marginal cost, or the derivative of R equals the derivative of C. Questions how I got this formula. You won't have to duplicate this. I just want you to understand why it works. I mean, we did some basic math. Okay, so let's try this then. A local factory has a cost function C of x equals 84 plus 1.26x minus 0.01x squared, yada, yada, yada. And a price function of P of x equals 3.5 minus 0.01x. Determine A, the maximum profit for the company, and B, the product level at which the marginal cost begins to increase. Let's focus on A. In order to determine A, I should write down a couple things. Okay? First of all, we know C of x's are 84 plus 1.26x. If you don't want to write it down, that's fine. You're going to write it right here. 2, 3, 4 zeros, x to the third. And my price function is equal to 3.5 minus 0.01x. Let's use that to determine our revenue, because we know if we're going to maximize profit, we have to take the derivative of the revenue and set it equal to the derivative of the cost. How do I find the revenue function? P of x times x. X times P of x. All you do is distribute an x. And that actually, that's actually something you do a lot in probability theory and some other courses as well. It ends up being that you just multiply the item through. 3.5x minus 0.01x squared. So, if we want to maximize profit, what equation do I have to set up? When is the marginal cost function equal to the marginal revenue function? So I need to take the derivative of C. What's the derivative of that? What's the derivative of the revenue function? Wait a minute. 3.5 minus 0.02x, isn't that the same as our price function? No, it's not. A lot of times it will look similar, but when you take the derivative, you notice that some of the constants will, or some of the coefficients will change. So it is different by just a factor of 2. Okay. So don't think that you could just write one down for the other. Laura Piper, what cancels off? Oh, she wasn't paying attention. Never mind. Yep, 0.02x's. Well, it's just last time you had the answer, so we just went right back to you. I just thought that would be good. Minus the 1.26, and I get 0.00021x squared equals 3.5 minus 1.26, 2.24. Marlene, you have a question. Sure? Divide by 0.00021 and square root, and you get x is 47.62. Nope, that's the number of items. So the way we find R of X is we take X and we multiply it by P of X. Yes. So, and your P of X is your price function, which they gave you. Now, you guys, we could have a debate about, this is not an integer, and so you can't really produce 0.62. So technically, we'd have to see whether or not it's cheaper to produce 47 or 48. Let's not worry about that. Let's just use the decimal for the sake of the mathematics here. We'll figure out what it is. Question, Kyle? Nope, not necessarily. That would be assuming you have a symmetrical curve, or you just don't know the nature of it, so you don't know. Oh, the problem says determine the maximum profit. How do I determine the maximum profit? No. Plug X into what? Guys, if we want to figure out the profit, we have to go like this. We have to take the cost, the revenue of 47.62 items minus the cost of 47.62 items. So once you plug those into the original to those functions, so you have your cost function right here, you have your revenue function right here. Plug them in, subtract them, and that will give you your profit. Yes. I divided by 0.0021. Oh, we did? Oh. Oh, I'm sorry. I'm sorry. I looked at the next problem. Yep, 103. 0.28. Yep. Yeah, that's the number of units. We solve for X. X represents the number of units. So we have to plug 103.28 into here. And that will calculate your profit for you once you plug that in. Now, part B goes really quick. The product level at which the marginal cost begins to increase is the inflection point. Does the inflection point happen at the first derivative or the second derivative? Second derivative. So the first derivative gave us 1.26 minus 0.02x plus 0.00021x squared. So the second derivative, I have to find that and then set it equal to 0. What's the derivative of this? Yep. Very good. Plus 0.00042x, and we set that equal to 0. We took the second derivative. Our first derivative is right here. Now we took the second derivative, and that will tell us the point at which marginal cost begins to increase again, which is an important spot. Solve for that. 0.0042x equals 0.02. Divide by 0.00042, you get x is equal to, that's where you get your 47.62. That's your number of items when it starts to, then when the marginal cost function begins to increase again. 103 is the number of items that we produce in order to maximize the profit. In order to maximize the profit, you type 103.28 in your revenue function. Minus, yeah, I'll plug that in. Let me write the assignment on the board quick. And I'll plug it in. 6 and 7 are like what we did on the front of the notes. 12, 13, 15, 16, similar to what we did on the back. Question. $47.62 is the number of items at which the product or at which the marginal cost begins to increase again. Yeah, so it's going to start to cost exactly. So at the second derivative equal to 0, the marginal cost function begins to increase. So you're going to end up paying more to produce more items. It's going to start costing you more than it was before. Yeah, very good. I took the derivative. This is the derivative of c of x. This is the second derivative. So you guys want to know what that profit comes out to be? What? Oh, sorry. Some things were dropped off. Catch it if you need it. He wants to know what it comes in when you plug in the calculator correctly. So we've got 1 second. 3.5x minus 0.01x squared. Table. We're going to produce 103.28. Berkey, this problem's for you. 254 is what you get for your revenue. 184 is what you get for your costs. So that's a profit of $70.